so on page 9, we're doing the f function minus the g function for these things. And basically all we got to do is, we'll start up here. I'll be a little bit overly specific. So to find h, we're going to do f minus g. Cool? And then just plug in those functions. So if I want to know h, I'll take the f. And I know the f is 3x plus 2. Okay? And then we're going to subtract x squared minus x. Now, okay, there is your biggest difference between adding and subtracting functions right there. The biggest difference is these brackets. All right, because I'm not just subtracting the x squared. We got to subtract the entire binomial. Okay, we subtract the whole thing. So before we combine terms, what do we got to do before we can combine all of our terms? Scoot up. If I can move it. Yeah. Here we go. Let me ask you, what on this do I need to get rid of before I can combine like the 3x and the x? What do I have to get rid of? The what? Well, the brackets, the parentheses. So how do I get rid of these things? Give you a hint, it has something to do with that negative. What can I do with that negative? Okay, let me put it this way. What if I have a negative 1 right there? If I had a negative 1 out there, what would you think to do with it? Distribute it. That's exactly what we're doing. We're simply distributing the negative. Cool? So I got h of x equals 3x plus 2. We didn't do anything to those ones. And so the x squared becomes a negative x squared, and the negative x becomes a positive x. Cool? Because we got to subtract the whole thing, not just that first term. Now you can combine them. So how many x squares do you have? 1. Well, it's got a negative in front of it, so it's a negative 1. All right. Combine your x's. How many do you have? 4. I got 3 over here, and I got 1 over there, so that's a total of 4 x's. How many units or how many constants do we have? 2. I have a constant of 2, so plus 2. And that's your new function. Okay. That is what happens when you, that's the result when you do, hey, take the f function and subtract the g function. That's what you get. Cool? Do you think you can do letter B on your own? Well, do you think you can try it? You can use the letter A as an example. I'll give you a hint. It's just like letter A, but with different numbers. Works the same way. Cool? So give it a shot. I'll leave that up there like that. And give it a shot. Pause that real quick. Pause. I'm saying most people who take it actually at least got most of the way through it. All right. It's just like the one on the left. You start off, we wrote the F, we wrote the G, but we put the G in parentheses, so we subtracted the entire thing. All right. And then we distribute the negative and combine our terms. At bare minimum, write it all down. But do we have any questions about letter A or letter B? Anything you want to talk about? All right. Sweet. Anybody still writing? Still got 3 people writing. Take another 15 seconds, finish writing up. And we're going to skip letter B, letter C, I mean. And we're going to do letter D. Cool? So let me ask you this. Letter D. Can I combine those two, subtract these two as they are right now?
No.
No, I can't. I got to multiply these out. All right? And so just apply your PEMDAS to them. We're going to multiply them all the way out, and then we can subtract them. Okay? So here we go. Which one you want to do first? You want to do F first or G first? F? Sounds great. So we'll start with F. I'm going to pick a different color. So this is the f of x. All right, so if I were multiplying this out, think of your PEMDAS. What would you do first? We're going to square it. Okay, so we'll take care of the squared first. So x plus 1 times x plus 1. All right, just like 4th grade math. What is 1 times 1? 1. What is 1 times x? X, or 1x. All right, move over to the x. What is x times 1? X. Again, what is x times x? X squared. Now what do you do with all those? You add them up. Good. So I got x squared. How many x's do you have? 2. And you have a 1 over there. Okay, so that took care of the squared. That's done. Follow your PEMDAS. After we square it, what are you going to do? We're going to take care of the plus 2, or we're going to take care of the times negative 3? PEMDAS. Exponents, then multiply, then add. All right, so we got to multiply by negative 3. All right, so I'll take my answer. I'll switch colors. Because Mr. Hunter just wants to switch colors. We'll do blue. All right, so times negative 3. What is negative 3 times 1? What's negative 3 times 2x? Negative 2x. What's negative 3 times x squared? There's a 1 right there. What's negative 3 times 1? Negative 3. So negative 3x squared. All right, so we took care of the squared. We took care of the times negative 3. What's the last thing you got to do? You got to add the 2. Oh, you're right. That's supposed to be a 6 right there. Thank you. So we'll add the 2. Which, do I add it to all of them or just the negative 3 over here? Just the negative 3. It's just combined terms. So my f of x, all multiplied out, is negative 3x squared minus 6x minus 1. That's your f. Cool? All right. Let's do the g. I'll scooch over to the right. G of x. And I'll start with brown again. All right. What are you going to do first on the g of x? You take care of the squared. It's your PEMDAS. Take care of your exponents first. So, x minus 3 times x minus 3. All right. So, what are we going to put right here as our first number? 9. Good. Because negative 3 times negative 3 is 9. My pen's not changing. All right. So, what are we going to put next? Negative 3x. Good. What are we going to put right there? Good. Another negative 3x. And then what are we putting over here? X squared. Good. So you got x squared. How many x's do you have? Negative what? Negative 6 plus 9. I think I heard somebody say 9, so I was like, what? That's okay. All right, so we squared it. What's the last thing you got to do with the g? Subtract 4. Go for it. Subtract 4. All right. I don't know why that popped in my head. Just go with it, okay? So 6x plus, what, 5? Yeah. So g of x is that guy. Cool. So those are your two functions. What are we supposed to do with those two functions again? Subtract them. All right, the initial question was, what is f of x minus g of x? So here's what we're going to do. You can do it one of two ways. I can either write them out like this, okay? Or I can write them out like this, like an old school math problem. So negative 3x squared minus 6x minus 1. And since we're subtracting, I'm going to do negative x squared plus 6x minus 5. Can anybody tell me what we did to that second function? How did I change it? Yeah, we switched, well, not just the x squared, but I switched all the signs. Why did I switch all the signs? it's a little simpler than that. Remember, it's f of x minus g of x, right? If we're subtracting them, I basically, since I'm switching the sign on the outside, I got to switch the signs on all three of those. And that means h of x would equal, I can move that up, negative 4x squared. How many x's do you have? 0. Those cancel out. How many units? Negative 6. And that would be your final answer. Cool. This is actually one of the few times that your final answer is actually simpler than the originals. All right? It does happen from time to time. Okay? Just being honest. Not as bad as hard as he's going to get, okay? That's about as hard as he's going to get. So turn the page. Let's keep rolling. All right. To the right is a blueprint for a picture frame. All right? So they give you a blueprint for a picture frame over here. And you might notice, I don't know, can y'all see them on your page? Do y'all see the little ones on the side? Can y'all see those on your page? All right, cool. Good. I didn't know how well they printed. I forgot. So here we go. To the right is a blueprint for a picture frame. Use it to help James find the area for the frame. Okay, so the ultimate idea is to get the area of just this outside frame. Okay, that's the ultimate goal. So first things first, they say write an equation f of x for the area of the outer rectangle. Okay. How do you find the area of a rectangle?
Oh, divide.
You don't have to divide. A squared plus b squared. That's Pythagorean theorem. What's the area of a rectangle? Huh? Length times width, or base times height. We just take one side and multiply it by the other side, right? So for this one, for f of x, remember this is the outer. What's your outer width? Anybody? What's the outside width? X plus 2. That's the outside width. All right, it's base times height. So that's the base. What is the height? X. They give it to you right there. Cool. All right, and then we'll clean it up a little bit. So go ahead and, if we're going to multiply it out, what is x times x? X squared, good. What is x times 2? 2x. Cool. And I'll just label this real quick so I don't forget. This is the outside. Okay? All right, write an equation g of x for the inner rectangle. So this is the inside. So again, a rectangle, what's the area of a rectangle again? It's base times height. There you go. So question. Let's figure out the base. If this is x plus 2, what would this right here be? Huh? Well, let me ask you this. Shh. All right. If I'm going from this outside right here to the inside, are we adding something to it or are we taking something away? You're taking something away. I'm taking something out over here, right? Because I'm making it shorter on the right. Am I making it shorter on the left too? This means yes, this means no. Yes! Okay, so my outside is x plus 2. How much am I taking off on the right? 1, right? So I took off 1. How much am I taking off on the left? 1. So, reduce that. What's x plus 2 minus 1 minus 1? X. So the inside width is just x. Cool? It's the x plus 2 minus those two outside pieces. Cool? All right, let's do the height. Well, the original is x. And what do I got to do to get just the inside piece? What do I subtract on bottom? What's that distance down there? Come on, y'all. If I'm going from the outside to the inside, I'm taking away the top piece, which is how wide is this top piece? 1. Okay, we're taking away 1. How wide is this bottom piece? 1. So we're taking away 1. What's x minus 1 minus 1? X minus 2. So the height is x minus 2. So base times height is x times x minus 2. All right, that's the base times the height of the inside rectangle. Okay? So multiply it out. If I distribute, what's your first term going to be? X squared. What's your second term going to be? Good. So that's your inside rectangle. Cool? I know it's Monday. Not sure I really want to be here either. Hey, Paul. I know you don't want to be here, but at least, act like it for my sake. Thank you, sir. All right, letter C. Write an equation h of x to represent the area of just the picture frame. Okay? So far I got an outside and I got an inside. If you got the outside area and the inside area, what do I got to do to these two to just get the frame, the part that's darkened? What would you do to those two? Would you add them together?
Yes.
Okay. If I took this area, the area of the outside one, and added the area of the inside one, would that leave me with just the outside border? If I added those two areas together? You sure? No. If I add them together, let's put it this way. I got a sheet of paper right here, okay? You fold it in half. Now I got a hole in it, right? Right, you look amazed that I made a hole that quick. I got a hole in it. What did I do to this piece of paper in the middle? I took it out. What is a mathematical term for taking it out or getting rid of it? Subtracting it. All right, I took the whole piece and I subtracted the middle, right? All right, so if my F is the whole piece, wow, I just erased it all. If my F is the whole piece and my G is the middle, what am I doing to those two to just find the outside? You're subtracting. So it is f of x minus g of x. It is the outside one minus the inside one. That'll just leave me with the border. Cool? So here we go. Plug them in. Your f function is, what was it? So h of x equals, that's what, x squared plus 2x minus, and in parentheses, we're going to put x squared minus 2x. Okay, that was the hard part, was building it, was thinking, what am I going to do to get to that point? All right, from here it's easy. What are you going to do? Give you a 10, it has to do with the negative. You just distribute the negative. So if I distribute that negative, that's x squared plus 2x. This x squared right here becomes what? Negative. This 2x over here becomes positive. That's a square. What did I write over here? That's negative x squared plus 2x. And then combine your terms. All right, how many x squareds do you have? None. Exactly. I got 1 over here and I got negative 1 over there, so that is none. How many x's do you have? 4. I got 2 here, I got 2 here. So h of x equals, I'll write over here, h of x equals 4x. That is the area of just the frame. Thank you. Cool? So this is kind of how your homework's going to work. It's either A, going to give you two functions and just say, hey, subtract these two. Or B, it's going to give you some sort of situation and say, hey, what's this and what's this? And I'll give you a hint. The topic of today's unit is subtracting. So what do you think you're going to have to do to those two? Add them. Good job. That's exactly what we're going to do. So subtract them. All right, and then it's going to ask one more question like this. Letter D. If x was 15, what is the area of the frame? Well, which function, f, g, or h, represents the area of the frame? H. Exactly. F was the outside, g was the inside, h was the whole, was just the frame. So if I want h of 15, we're going to plug that in for x. What is 4 times 15? 60. So if x was 15, it's 60. I think it's square inches. I think the whole thing is in inches. No, you don't have to put your units, but that's what it is. Cool? That's what this whole thing is. And I'm going to stop right there. All right? Any questions about what we did here at all? I know it's Monday, but still.